A warm welcome to all the viewers. Today's session is going to be quite special, especially for all those young researchers who might have heard about AMOS, that is Analysis of Movement Structures. It's a software, an advanced version of IBM SPSS. So, how is this software used? How do we draw a model in this software? And how do we assess the multivariate normality, which is not possible to be assessed in IBM SPSS? So we can do a number of things in AMOS, and it is quite famous for doing structural equation modeling. So let us go ahead and learn it quite efficiently and effectively to help us in our research. What is structural equation modeling? SEM is a comprehensive framework for testing complex relationships between multiple variables, which include both observed and latent variables, involving measurement and structural models. In my previous videos, I have explained what is a measurement model, what is confirmatory factor analysis. Both of them are done in AMOS. So you might go back to check on the video on confirmatory factor analysis and measurement model. Multivariate normality. This is the topic which we are going to explore today. We will of course be going ahead with the analysis of our data in AMOS, wherein I will show you how to assess the measurement model and how to build a structural model and assess the different parameters of a structural model as per the objectives of your research. For now, let us understand what is multivariate normality. It is an assumption for using maximum likelihood estimation, MLE, and if this assumption is violated, the results from AMOS might be inaccurate or biased, because the model which we are building up in AMOS, the structural equation modeling, needs this assumption to be fulfilled, which says the data should exhibit multivariate normality. Normality assessed on the basis of all the variables which are included in the model. Maximum likelihood estimation is a method used to estimate the parameters of a statistical model. It works by finding the parameter values that maximize the likelihood function, which represent the probability of observing the given data under the assumed model. It is assessed through Mardia's coefficient, which is a measure of multivariate kurtosis. So often there's a confusion in the researcher's mind that how to assess multivariate normality, what is Mardia's coefficient, and where do you find it in AMOS? So let us go ahead in AMOS and learn how to build a measurement model and then assess the Mardia's coefficient. So here am I in my AMOS. This is AMOS version 24. You see here a portrait kind of a layout in which I can draw my model, and in case I want it to be changed to a landscape, I can easily do it from go to view, interface properties, and herein I change it portrait to landscape. It seems to be quite more comfortable to draw a model over here. Now what do I need to do next? Special thing about AMOS is that it accepts data from .sav, that is SPSS file, as well as Excel file. So for now, I'll just import my data. You go to this tab, select data file, click on that, and then go to file name, and my file is saved on the desktop. This is the file, SAV file. I clicked on open and OK. Now I click on this tab, list variables in dataset. So see, all the variables in my study, if you have watching my videos, my previous videos, I've explained that we are using this sample data for all kinds of analysis, wherein FQ stands for food quality, CA stands for cultural authenticity, SQ stands for service quality, VM stands for value for money. These are the four independent variables which are used to predict the dependent variable, which is behavioral intention BI of tourists. And each of these has four indicators measured on Likert 5-point scale, right? So this is all about data. I've explained it in my previous videos. You can go and watch those videos as well. Now, what should I do? First, I need to build up a model. So the first thing which I need to do in over here is I need to build a model. Build a model which includes all of my four latent variables, independent variables, and one dependent variable, which is again a latent variable, which has four indicators, BI1 to BI4. How do I do that? I click on this symbol which says draw a latent variable or add an indicator to a latent variable. So what do? I simply draw it like this, and then I click 1, 2, 3, 4. Quite simple, right? Because there are four indicators. Now, again I draw one more, and again I go to the middle. When the border is red, I click 1, 2, 3, 4. Again, 1, 2, 3, 4. Again, 1, 2, 3, 4. Got it? So we've drawn four independent variables of our study. Let us draw the dependent variable behavioral intention as well, which has four indicators like this. Now I will be selecting these things, say FQ1. See, this is FQ1, FQ2, FQ3, FQ4, like this. Then CA1, CA2, CA3, CA4, then SQ1, SQ2, SQ3, and SQ4. The last independent variable, value for money, VM1, VM2, VM3, and VM4. Behavioral intention, which is the dependent variable, BI1, 2, 3, and 4. So all of our variables of the study, the independent and the dependent variable, are here now on the canvas, on the landscape. So now I need to just set them out. I can click cross over here now. I don't need the list of variables for now. Now what I need to do, I'll select them using this. So you see, select one object at a time, select all objects, deselect all objects. Rotate the indicators of a latent variable like this. So you see, I've rotated it like this. I want a clean model so that I can have done it like this, so that I can accommodate all of them on this landscape sheet. Now I need to name them. So what should I name them? Just click on here, object properties, variable name FQ, object properties, variable name CA. So I click right click, variable name is CA. Third one, variable name is SQ. Fourth is variable name VM, right? And the dependent variable name is BI. One important thing over here is, after I have mentioned the names of these latent variables, enter the name of these latent variables, I need to press on this button which says preserve symmetries. So now the symmetries are preserved, and now I can move them. So you see now this whole moves as a single entity, and I can place it anywhere I want to make my model a little more beautiful like this, and everything is quite visible, right? So this is the way I draw the model. And for this one also I need to shift the indicators towards the right end. How do I do that? I click on this one, rotate the indicators, and simply do like this. Now all these circles which you see over here are the error terms on each of the indicators. AMOS works on covariance based structural equation modeling. So we need to covary all the variables in the study for assessing the measurement model. We have to covary them, right? And how to put the value in these error terms? Just go to the plugins. I've already installed the plugins from StatWiki by Professor Gaskin. You can search on it Gaskination, from where you can get all the plugins of AMOS. So here it says name unobserved variables. So I just clicked on them and all the error terms are right here. Now what I need to do next, I need to draw covariance between them. How do I do that? So just select on this double arrow which is draw covariances. It is mentioned over here, double headed or arrows like this. So once it turns red and the other one turns green, leave the mouse like this, and everyone needs to be connected with each other, right? So this is the way I'll connect all of them. You see, of course I can beautify this model, but for now I'm just showing you how to draw a basic model, a measurement model in SEM, wherein I need to connect all of them. So now you see here, each one has to be connected with 1, 2, 3, 4. So I can count them easily: 1, 2, 3, 4. 1, 2, 3. Which one is not connected? You see, this one was missing, CA and VM. So 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. Right? Because we are having 5 latent variables, each one has to be connected with all other 4 variables. So this is how I made the covariance connections between my latent variables, and now I'm going to assess the multivariate normality which we are studying through this video presentation. I go to view, analysis properties. You see here estimation is maximum likelihood, which I explained you in the slide also. Rest is all okay for now. We go to output, and in output you see here test for normality and outliers. This is the one we need to click for now, and here we can click on standardized estimates, squared multiple correlations, residuals, indirect, direct and total effects, though we will not be using them for the purpose of this video. For the purpose of this video, I'll be just assessing the multivariate normality. So I'll click on test for normality and outliers. That's it. Close this thing, and now click on calculate estimates. Now once you hover over to this, it's quite comfortable to be used because it itself says calculate estimates. You see, every button, every symbol which is mentioned here has a clear and simple explanation of how is it used, what function does it do. I need to save this file first. I'll click on file, save, and I may build up a this thing AMOS folder on my desktop, AMOS models on my desktop. I save, click on save. Now this file has been saved under the AMOS models. You see here AMOS models folder which I created on my desktop. Now what next? Now I need to deselect them all like this and then click on calculate estimates. See how fast it does the calculation. It has done the calculation. So you see here the calculation has been done. In the next video, we'll be discussing it further. What are unstandardized estimates, standardized estimates, what to look in for, what is this chi-square and everything. For now, let us just concentrate on multivariate normality. So I click on view text to open the report wherein I will get the results of this measurement model analysis. You see here? Yeah. So now I want to see assessment of normality. You see here assessment of normality. So now when I look at this critical ratio, it is 19.167, which is the Mardia's coefficient of multivariate normality. This has to be lesser than 5 as per the reference given by Bentler. Now if this has to be lesser than 5, then what should we do? We have certain measures, certain methods to improve the multivariate normality. One of the ways is that you look at the observations farthest from the centroid, Mahalanobis distance. Now you see here the gap between any two observations, if it is quite big and quite unusual, then you might say that they might be the outliers. They might be significant outliers in your data, and you need to remove those respondents. You remove those responses from the data sheet and again assess the multivariate normality. Now, if we look at this Mahalanobis d squared distance, now you see here 35, 36, 37, 38, 40, and then it climbs suddenly to 45, a difference of 5, and then 68, 73, 88. So the distance is becoming larger, and the significance value is also lesser than 0.05. That means they may be quite significant outliers. They may be significant outliers, and then you can take a decision to remove them one by one and then again assess the multivariate normality by coming over here and looking at the critical ratio, which has to be lesser than 5. Another way of doing it is that you do a bootstrapping method, which I will show you in the next video. I hope the video was quite interesting and knowledgeable for you.